Hello, students. I want to inform, I want us to carry out some extemporaneous preparations, so calculations on extemporaneous preparation, which is popularly known as compounding. Why do we have to compound some medication? Yes, there are some medications, there are a set of medications that we need to compound for children. Why? Because some of them doesn't come in syrups or suspensions, but rather they come in tablets. And some children may likely come down with a disease condition at which they may readily need some of these tablets for them to alleviate or for them to carry out a treatment plan on them. Now, this compounding is all about transforming a tablet or suspending a tablet into a suitable vehicle. That is, transforming a solid particles into a liquid particle, a liquid substance. That is, we going to the only thing we do now is to calculate the considerable amount of spironolactone with a dose of 14 milligram, a daily dose, in the period of 2 weeks. So from there, we can be able to know the exact amount of tablets that we need for these durations and the frequency with the dose. Now, the first thing, whenever your prescription comes to your doorstep or your table, the first thing you do is for you to know the number of tablets that you're going to powder. How do we do about that? So you said number of tablets equal to. So how do we know about the number of tablets? A dose of 14 milligram, that is per dose is 14 milligram. 14 times the daily dose is just once daily, that is 14 milligram daily. So that will be 1. Then times, instead of writing 14 days, we decided to write 15 day. Why? Because some of these medications, probably accidentally, some of them may pour on the floor. That's why I decided to add an excess of 1 day. Some of them will be accidentally pour on the floor, maybe at the point of administrations from the mother or to the child. It's accidentally pour on the floor, and we need to, the calculation we want to make, it will be a period of 14 days. So accidental maybe pour on the floor, or maybe some of them will be found on the wall of the measuring substance that they use to kind of administer the drug to a child. So you can see that it will affect the duration. Instead of the 14 days, probably if we were to calculate based on the 14 days regimen, then probably the child may likely take for just maybe 12 days and the liquid will finish. So you can see that the regimen for 14 days was not achieved due to the fact that some of them maybe pour on the floor, or some of them are fine on the wall of the measuring substance. And that's why I decided to kind of make it 15 instead of the 14. That is 1 day added. Sometimes sometimes I decide to add maybe 2 days excess, so as to kind of, the point of administration from day 1 should be suitable to day 14. But if it is exact, you decide to calculate for the exact 14 days, then there will be a higher chance at which these medications, like I've told you, some of them will be pour on the floor, or some of them will be found on the wall of the measuring cylinder, or any other measurement of substance that you use in measuring, and it will surely affect the duration. So now let's calculate the number of tablets as 14 times 1 times 14. 14 times 1 times 15. We have 210 milligram. Now, how do we know the number of tablets? Because this is the total amount of milligram we need, or this dose, with the frequency and the duration. Now, if per tablet, from at the topmost layer we have 25 milligram per tab, which means for one tablet is equivalent to 25 milligram, which means this manufacturing a particular tablet is just 25 milligram. Then X tablet, we don't know how many tablets will be present in 210 milligram. Now when you do your ratio and proportion, this 1 times 210, right? Then X times 25, you will end up into what? 210 divided by 25. So 210 divided by 25, that will be 8.4 tabs. That is, decided to short it. It's supposed to be 8.4 tablets, but I decided to short it. That's 8.4 tab. Now it will be very, very impossible for we to have the exact 8.4 tablets. But the next thing we do, whenever we calculate, we want to know the number of tablets based on the dose and the frequency with the duration, and we end up into a decimal. The next thing you're going to move to the next whole number, which is 9 tablets, because you can't be able to obtain exactly 8.4 tablet, to be very, very impossible. So you move to the next whole number, but at this point in time you're going to multiply this by 25, since per tablet is 25. So that 9 times 25, you have 225 milligram. 225 milligram. So this is the entire milligram that is needed. With this, what this means is that at this 225 milligram, when you divide it by 25, you end up into 9 tablets. So instead of using 210 milligram as a total milligram, we are not using this, since it end up into 8.4, a decimal number. Then we move to the next whole number. We're not going to use this, but rather we'll use this as our calculation, subsequent calculations, because we're using 9 tablets, not 8.4. Now we've gotten the number of tablets we need, which is just 9 tablets. So these 9 tablets will now be transferred into a clean, dry mortar, and will be crushed by a pestle. So after it has crushed to powder, then the next thing, you need a suitable vehicle. What we call a vehicle, a suitable vehicle. When we said this vehicle, they are just they are syrups, the vitamin C syrups, the B complex syrup, the multivitamin syrups. Why we call them vehicle? Because we going to, it is through these syrups that we're going to transform this powder, that is, we're going to transfer incorporate this powder into that, this powder will be suspended in this liquid. I get it. The suitability now the time, because whenever you're wrong about, or you don't have an idea on what type of syrups you're going to use, or the vehicle you're going to use, then they will whenever you decide to kind of mix this together with the powder tablet, the tablet you've powdered, it will coagulate. You understand? So there won't be uniformity in the mixture. So the coagulation will take place. It will kind of coagulate. So the suitable vehicle is very, very important. There are a lot of charts that contains tablets. It contains a lot of what's it called, tablets that are readily or have the potential of compounding with their suitable vehicles. But there is another hint that if you happens to have this, then you don't even bother in a kind of going for those charts. Or for example, you don't have those charts at your disposal. So the first thing you will do, when what will come into your mind, that you should know the state, this the pH level of the tablet you are compounding. If it is acidic, then you need vitamin C. If it is basic, you need B complex. And if it is neutral, at least it is neutral, it is not acidic, non-basic, then you need multivitamin. Please take note of that. Acidic, whenever you browse the state or the pH level of a particular tablet you are compounding. If it is acidic, you will just ask so tablet like this spironolactone. You can even ask Google, spironolactone, is it acidic or basic or neutral? So based on the experience, spironolactone happens to be neutral. So we need the suitable vehicle here is what? Multivitamin syrup. We need what? Multivitamin syrup. So this is a suitable vehicle, that is a liquid preparation that we need to reconstitute, or to kind of allow this powder to be suspended into. Are you getting it? Then we need, now at this point in time, we need to carry out a calculation so that we know the accurate amount of the volume, or the accurate amount of the volume of multivitamin syrup that is needed to kind of incorporate this 9 tablets. Now you can decide to use 2.5 mil per, at this, for example, you decide to use, you can use 5 mils, you can use 2.5 mil. I decide to use 2.5 mil, 2.5 milliliter, equivalent to from the dose, from the on the prescription is 14 milligram. I get it. What this means is, For every 2.5 mil you fetch from this preparation that you're about to make, you're going to obtain what 14 milligram. Sometimes you may decide to make it 5 mils, but you have to be mindful about your bottle capacity. If you have 100 mils bottle capacity, you have to know how to kind of titrate the volume, that is the dose that you need, that is the dose, the kind of volume that you're going to kind of give to have an exact dose from the prescription, which is the 14 milligram. So you use 2.5 mil, 2.5 mil in 14 milligram. That's to tell you that for every 2.5 mil you fetch, you're going to obtain what 14 milligram. So this is the one I'm going to use. You can also decide to use 5 mil in 14 mil. That is, for every 5 mil you fetch, you're going to have 14 milligram. It's still the same, but you have to be mindful about your bottle capacity. Majorly, multivitamin syrups, vitamin C syrups, and so on, they happens to be 100 mil capacity. So there is a way at which you're going to titrate these volume so that you shouldn't exceed beyond the 100 mil. So this 2.5 mil in 14 milligram, that is 4.5 mil equivalent to 14 milligram. Then X mil, we don't know the total amount of volume that we need to suspend these a powdered 9 tablets, powdered spironolactone. Now that will be the 9 tablet is what's 225 milligram, right? So now using your ratio and proportion, X should be equals to 2.5 times 225 divided by 14. So 2.5 times 225 divided by 14. You're going to have 40.17. Approximately, we need a total of 40 milliliter. We need a total of 40 milliliter to reconstitute this 9 tablet, that is to kind of allow this 9 tablet to suspend it. Now already you've crushed the tablet into powder in a clean dry mortar. Then the next thing you do is to form a paste, that is you add bit amount or a little amount of these amount. Already you're going to measure, or you're going to use a measuring cylinder to measure exactly 40 mils. So these 40 mils, now you make a paste with these 40 mils, that is you transfer a little amount of this from these 40 mils into the mortar containing the powdered 9 tablet of the spironolactone. Then you make a paste, you mix it so that the particles, the tiny particles within it, should be uniformly mixed. Then you add a bit to the point that after you've been becoming a bit satisfied with the liquid or the volume, then you transfer it into a clean dry calibrated bottle. Are you getting it? After you transfer it, then you still continue adding, because you don't add the whole 40 mils into it. As you are adding, the little or the particles of spironolactone that are still on the wall of the motor will now, you try to allow them to be suspended or to be incorporated within this vehicle, which is the multivitamin syrup. So after you use it, you transfer. You still fetch a bit from this measuring cylinder, the same 14 mils, that is within, you're still using that same 14 mils that you measured initially, by kind of transferring it or adding into the motor bit by bit, so that all the particles of spironolactone will be readily, or all of them will be within or be suspended in this 14 mils preparation. And after then you now kind of level the product. Label the product. Are you getting it? You instruct the patient or the mother that comes for the drugs. Instruct the mother that you should shake the anytime that you want to use it. They should shake the bottle very well before you, because it's a suspension. So some of these particles will be beneath the bottle. So whenever they want to use it, it should be readily shaked. That is, the bottle should be shake before use. And that's all. You're done with the compounding. Very simple. Have a nice day, and thanks for listening, and wishing you success in your academic pursuit.